Alright, so here we have the idea we're trying to understand the area of a circle and how that formula is created. So in this app, you see you've got this top circle where I have the area, circumference, and the radius already determined. And then I've got where I've taken these sectors and actually overlaid them together uh, to make a pattern, and we're going to see what does that start to look like. So with only 4 sectors, it's kind of hard to see. You might have some guesses, but then I'll tell you to kind of expand that. Say that um, instead of 4, I know I said 12, but 16 does the same idea. What do you start to notice? Well, as these pieces are cut and laid side by side going through this, you can see, well, I get a straight side thanks to the radius. And then I've got the little curved side that I had with 4 starting to flatten out a little bit because that piece that I have of the edge of the circle for that sector becomes smaller and smaller, so it has less curve to it. And I can start to see, well, maybe that's starting to look a little bit like some sort of four-sided shape, some quadrilateral I've worked with before. So if I start to increase the numbers, well, here I am at 40. Those sides, the top and bottom of my quadrilateral here, they're looking virtually flat. They're not exactly flat. They'll never be completely flat, but to the naked eye, they're looking very, very close to as if that was a flattened side. And I can say, oh, that looks really close to the idea of having a parallelogram. All right, and how do I find the area of the parallelogram? Well, I do the base times the height. So I just need to find the base and the height of my parallelogram here. Now, if I expand this out even further, the smaller and smaller those pieces become, the narrower and narrower the sector becomes, and the straighter uh, my sides become, to the point where when I get to 180, this virtually looks like a rectangle. Now, is it a rectangle? No, but it's very close, and I could continue to split and make tinier and tinier sectors of the circle and do this overlapping pattern, and it would be very, very close to a rectangle. Now, the area of a rectangle is the same as a parallelogram. It's base times height because a rectangle is a special type of parallelogram. So, using the same formula, whether I use a rectangle or the parallelogram, because the height will still be represented by the same thing, the base will still be represented by the same thing. So then it gets to the questions of actually let's compare the area of the circle to the area of this parallelogram. And I'm just going to bring it back a little bit, make it a little bit easier to see what's going on. Doesn't change it really at all, but it's nice to be able to see. So it says to create some segments, so I know I need a base, which I'll call this flat side here my base. And I'm just going to use a segment tool, and I'm going to do my best to kind of keep it as straight as possible going across here, trying to line it up the best I can. It's not going to be perfect, but that's okay. I just want to get really close. And then my height, I'm going to do the same thing here. Try to keep it as straight as possible. Don't want it to lock onto anything. See how it wants to lock there. Well, if it locks, that's fine. What we can do then is use the move tool and just move H so it's pretty straight as well. And then I can measure them. So I come here, I'm going to measure my distance or length. So I can click on it, and then I can click on my other one. And I can say, well, one of the reasons I'm off a little bit, again, I've got that extra height, so I need to kind of shrink this down a little bit. And I may need to pull this up a little. And I need to then straighten this one out a little bit more too, so it's all lined up pretty well. And say, okay, well, let's see what we've got here. And maybe a little bit, we'll say that's probably a little closer. Those numbers aren't perfect, but they're close. Again, I'm just doing it by hand, just trying to approximate on the screen using the segment tools I have. And I can say, if I look at that, well, if I find the area, I know that the area would be 12 and 52 hundredths times 4 and 6 hundredths. And if I look, even with my approximation of those tools that I had, I'm very close to the area of the circle. So I should feel pretty like I got an idea that this parallelogram, finding base and height, is a way to do it. And if I had a little bit better tools where I could find the exact height and the exact length of that side, I could probably get it to exactly the 2700ths as well. Again, these are both approximations because we're only rounding to 2 decimal places. Now the question is, well, where do these pieces come from on the circle? Well, if I look at this, my 4 and 600 side that I created, that segment HG, while it's not perfect, I can say that that's virtually my radius. And if I take it all the way out to 180, and I think about what's happening, the edge of each of these sectors is the radius. So the radius is just getting straightened up to create the height of this parallelogram. So the height is the radius. So that one's not too bad. Now we got to figure out this other side though, what we're calling our base, and how does it relate? Well, I know that if what I have left are my area and my circumference. So let's see, does it relate to either of those? So if I do 50 and 2700ths and I divide that by the 12 and 5200ths, I get something over 4. Seems a little high. I don't know of any relationship, but let's check out then if I did the 25 and 1300ths divided by the 12 and 5200ths. I'm getting something really close to 2. So then I have to do this a little bit of thinking, like why would it be really close to 2? And can I get it closer? Probably so. But think about, what does each of these little segments or curves relate to? And maybe if I take it all the way back out, I remember, well, those were the edge of the circle. If I take all the parts, all the edges of the circle, and put it together, that gives me my circumference. So if I think about, well, what's happened to the edge of my circle, or my circumference has been split in half. Half of it's up here with the edge, and half of it's down here with the edge. So this idea that that the circumference is double the base would make sense, because I have half my circumference on the bottom and half my circumference on the top of my parallelogram. So then the question is, well, can we relate this into a formula that will make any sense? So if we think about what we know that a parallelogram is base times height. And we know that the base in this case, we just said, was half of our circumference. And we know that the height was created by the radius. Now, that doesn't look very helpful. That's kind of confusing, doesn't make much sense. So maybe the idea here is instead, what is circumference? Well, circumference is diameter times pi, or 2 times the radius times pi. And then I've still got this radius out here. Oh, now we start to get somewhere, because my 2's cancel, and I'm left with radius times pi times radius, which is the radius squared times pi. Well, what is that? That's the area of the circle. So the way that we think about how do we get to the area of the circle is through the idea that we use this limit that if we split the sectors into smaller and smaller pieces, it becomes almost a rectangle. And from the rectangle, we know that's 1/2 the circumference times the height, which is the radius. And that simplifies to pi r squared.